today we are making sure that we can look at the equations for conic shapes and know what shape is going to be created. So, we've already gone over the 4 conic shapes. That's circle, ellipse, hyperbola, and parabola. And now we just need to identify the differences between the equations so that we know what these are going to look like on a graph. Now here are the rules for identifying whether or not these are going to be circles, ellipses, hyperbolas, or parabolas. So looking at this first one right here, if there is one square only, what type of shape is this? In the equation, if there's only one square, what shape is this? It is a parabola. Remember, I told you guys, the quicker you answer, the quicker we can be out of here. We could be, this is only 1 page of notes. We could be out of here and done with class by 11:30. All right. What about when there's 2 squares with the same sign and same coefficient? So we're looking at the squared terms. If they have the same sign and same coefficient, what are they? Say less. You guys saying less is the problem. Yes, good. Good, Lauren. Lauren's carrying us right now. This is a circle. When we have the same coefficient and same sign, it creates a circle. What about when we have 2 squares with the same sign but different coefficients? What shape does this make? Yes, good, ellipse. Whoops, I'm forgetting a letter. It's an ellipse. What about if there are 2 squares and one is negative? Yeah, this is hyperbola. Already quicker than first period. First period, I had to wait so long between each one of these. Good job, guys. All right, so now we're going to first identify what each one of these examples represents, what it will look like on a graph, and then it wants us to identify the attributes of each one. For example, if it's a parabola, it wants us to identify the vertex and focus. If it's a circle, it wants us to identify the center and radius. And if it's an ellipse or hyperbola, it wants us to identify the center. And I'm going to change these. I don't want us to identify the vertices and foci. What I want us to identify is the A and B value. So first, before we find all these attributes, let's look and see what types of equations we're looking at. So in example 1, what type of shape is this going to form? Yes, Lauren, exactly. This is a circle. What about 2? What's that? It's a parabola. Yeah, it's a parabola because there's only one square. When there's only one square, it has to be a parabola. What about example 3? What's this thing? It's not an ellipse, actually. Remember, we're looking at the 2 square terms. When they are being subtracted, yes, Kate, it's a hyperbola. Remember, hyperbola has subtraction between the 2 square terms. Ellipse has addition between the 2 terms, or it has the same sign. You can think of it as. So knowing that, what does example 4 represent? Oh, right, yes. This is an ellipse. Good. All right. So that was the easy part. Now, circle, we need to identify the center and the radius. What is the only way to identify the center and the radius when given the equation of a circle in general form? What do we have to do to it? I can't just look at a circle in the general form and know the center and the radius. Instead, it needs to be in standard form. How do I get a general form into a standard form? Yes, we need to complete the square. Good. So I'm going to complete the square for this circle. Now I'm going to have to complete the square twice, once for x and once for y. And we know that we're going to have to group the x's, group the y's, and get the constant to the other side. So that's what I'm going to do. I'm going to group my x's and leave a space to complete my square. Whoops, I said purple. I'm going to group my y's and leave a space to complete my square. And then I'm going to move that 1 to the other side. And because I left a space on the left, I have to leave a space on the right. Because I left a space on the left, I have to leave a space on the right. Now, what value, or how do I find the value I need to add in to the x quadratic to complete that square? Yes, divide the b value, which is -4, by 2, and then square it. So, what value do I need to add in? 4. Yes, that's what I'm going to add in to the x quadratic. And because I added it on the left, I must add it on the right. What value do I need to add into the y quadratic? Yes, it's again a 4. 4 divided by 2 is 2. 2 squared is 4. So I'm adding in a 4 here. If I add it to the left, I must add it to the right. So then, 1 plus 4 plus 4 is 9. How do I complete my square for the x's? Yes, we keep the same variable, which in this case is an x, and then we take our b and divide it by 2. So x minus 2 squared is our completed square. Same thing for the y's. I take my variable, which is a y, and I take my b value, and I divide it by 2. So I have y plus 2 squared is my completed square for the y's. And this actually is the completed standard form for a circle. I can now identify the center and the radius. What is my center? Yes, 2, -2. Our h value, the term subtracted from x is 2, and our k value, the term subtracted from y, is -2. What's my radius? Yes, the square root of what the circle is equal to. So the square root of 9 is 3. This is because, remember, the equation of the circle is set equal to r squared. So this is what r squared is equal to. So we have to square root that 9. Any questions on this one? I'd have to say circles are the easiest because they don't, or normally don't, have coefficients on them. So now, I have to say parabola is the hardest, actually. We have to only, now it is easier in that we are only completing the square once, right? We're only completing the square for the squared term, which is our x's. So what I'm going to do is I'm going to get the x's on one side and the non-squared term, the y, and the constant on the other side. Like so. But then, I know I'm going to have to complete the square for the x's, but I can't do it when there's an a value on the x squared term. So I need to pull that a out of my x's. And then I can leave a space to complete my square. And I can leave a space to complete my square. I'm sorry, a space on the right. What value do I add in to the x quadratic to complete that square? Yes, a 1. Because we take our b, we divide it by 2, and we square it. b is -2. -2 divided by 2 is -1. -1 squared is 1. Now, is that actually the value I added in? Right, Peyton, yes. I didn't actually add in just a 1. That 1 right here is actually being multiplied by this 2. So on the right-hand side, we're adding 2 times 1. So then, this side is equal to -2 plus 2 is a 0. So this is actually just -y. And I'm putting it in parentheses because that's how we normally see the equation for a parabola in parabolic form, is the variables are always inside a set of parentheses. And then I can complete my my x quadratic. How do I complete the square for the x's? What do I do? We write down our variable and then what? Yes, we take our b and we divide it by 2. So we have a -1. And this is actually in the form we need it to be. There's nothing else that needs to be done here. Where is my center? Oh, not center. I'm so sorry. Vertex. On a parabola, it's the vertex. Where is my vertex? Close, Lane. So remember, close, Sydney. Remember that when we're trying to identify the vertex or center, the h value is subtracted from x and the k value is subtracted from y. So what number is being subtracted from x? What's my h value? Not a -1, but a +1. Good. And what number is being subtracted from y? 0. Wonderful. So now that I know this vertex, it actually wants me to know where my focus is. Now, this is why the parabola is the hardest, because in order to know where my focus is, I need to know what my p value is. And remember, in front of our non-squared term is what represents 4p. So in this case, 4p is equal to -1. So when I solve for p is actually -1/4. And if I'm thinking about this parabola, I know it's a horizontal because the x is the term being squared. So it's a horizontal parabola, meaning it's either going to open up or open down. Because the p is negative, it means it's going to open down from your vertex, like so. Knowing it opens down and knowing our focus is a distance of p away from the vertex. What is the coordinate of my focus? Exactly. Our focus has the same x value as the vertex, right? It's on that same line. So our x value of the vertex is 1. But we're going down by negative 1/4. That means from 0, I'm going down negative 1/4. My focus is y value is negative 1/4. And if you need to, you can always sketch a little graph to help you identify these things. Or you can just graph it on your calculator or Desmos, either way. All right. On to hyperbola. We're doing well. That was the hardest part, to be honest. Now, again, we're trying to identify, what is it? The center and the a and b value. So in order to identify these things, we have to complete the square twice for a hyperbola. So I'm going to group the x's, group the y's, and get the constant to either side. Because there's only one x term, there's only the x squared term, this means I actually don't have to complete the square for the x's. This is already a perfect square. So I can leave it alone. I just need to complete the square for my y's. Now notice I have an a value on the y squared term. I need to pull this a value off of my y's because otherwise I can't complete the square. So I'm dividing negative 25 out of y squared, and I just get y squared. And I'm dividing negative 25 off of negative 100y, and I get a positive 4y. And I leave a space to complete my square, move the 125 to the other side. And what value do I need to add in to the y quadratic to complete the square? Four. Yes, because our b value is 4. So I divide it by 2 and I get 2. 2 squared is 4. So I'm adding 4 on the left. Now, is that actually the value I added into the left-hand side? Right, Peyton, exactly. That 4 is actually being multiplied by that negative 25. So on the right, I'm going to multiply 25 times 4, and that's the value I actually added in, or in this case, subtracted in. So then 125 minus 25 times 4, which is 100, is just 25. Let's do purple. Bring down my x squared, bring down my negative 25. How do I complete the square for the y quadratic? What does my completed square for the y's become? Right, exactly. You write down your variable and you take your b and you divide it by 2. And you get plus 2. Whoops, happened there. However, a hyperbola is never equal to any number besides 1. So, how do we force this thing to be equal to 1 instead of 25? Yes, you divide everything by 25. 25 divided by 25 is just 1. We place the x squared over 25 minus 25 over 25 makes the denominator of the y quadratic be a 1. And now this is in standard form. This is the standard form for a hyperbola. So I can identify my center, my A, and my B. Where is my center? What's my h value? The value subtracted from x. What's my h value? 0. What's my k value? The value subtracted from y. -2. There's my center. What's my a value? Remember, with a hyperbola, a is always under the positive term. So what is our a value? Now, yes, that's what our a squared is. So what do I do to get the a? Right. You take the square root of 25 and you get 5. So what is my b value then? What do I do to get my b? The other denominator. Right, you square root 1, which is just 1. So that's my a and b. And remember, this is a horizontal hyperbola, so my center is at 0, -2. That's here. And because it's horizontal, I count my a value left and right. So I go to the left, right. I'm sorry, to the left, right. To the left 5 and to the right 5. Those are my vertices. And I would go up 1, down 1. And remember, that's what creates my hyperbolic box. That my asymptotes go through. Any questions on this one? Kind of drew it very badly. All right, last one. Last one, and then we're done. Okay, an ellipse we do the same way. We have to complete the square twice by getting and also get the constant to the other side. But this ellipse has 2 separate coefficients on the square terms. So I'm going to have to pull both of those a values out. Now, I divide 16 off of 16x squared, and I'm left with x squared. I divide 16 out of 32x, and I'm just left with 2x. And I leave a space to complete my square. Same thing for the y's, but I'm pulling off a 25 instead. And I'm left with y squared plus 6y. And I leave a space to complete my square. So equal to, I add that 159 over, and I have a space and a space. All right, what value do I add into the x squared? This one should be boom, boom, boom. Let's just get this out so that we can leave. What value do I add into the x's? Right, yes. Remember, we take b, we divide by 2, and we square it. So 2 divided by 2 is 1, squared is 1. But we need to multiply that by 16, and that's what we add in on the right. What do we add into the y quadratic? Nine, yes, because 6 divided by 2 is 3. 3 squared is 9. What am I going to add in on the right, though? Not just a 9, but times 25. Good. And that all actually equals 400 when I add it all up. How do I complete the squares for the x quadratic? Yes, x plus 1, because you just take b and you divide it by 2. How do you complete the square for the y quadratic? Y plus 3, yes, because you just take your b and you divide it by 2. Now, ellipses are also always set equal to 1. What do we do to get this thing equal to 1 instead? Yes, divide by 400. Divide everything by 400. 400 divided by 400 is 1. 16 over 400 actually simplifies to 25 on the denominator. 25 over 400 actually simplifies to 16 in the denominator. Notice it's just always the other's coefficient, by the way. It will always work that way. So, knowing all this, where is the center of this ellipse? Yes, -1, -3. And remember, for an ellipse, the a value is always the bigger denominator. So what is our a value here? Which one is bigger, 25 or 16? Right, 25, so that's what a squared is equal to, so I square root 25, and I get 5. Therefore, my b squared is what 16 is, so what is b? Yes, square root of 16 is 4, and we're done. Whew.